Okay, what's a linear transformation? Well, linear transformation T is some rule that takes vector v1 plus v2 to the vector T of v1 plus T of v2. That's linearity. And you know, of course, if these are vectors and this is a matrix, and the transformation is defined by a matrix, then clearly this is going to be true. That's what you're used to saying. But these rules are stated a little differently, so you got to get used to the notation a little bit and what these rules are actually saying. Okay, so we have an example of a rule over here. But the other condition has to be that T of CV equals CT of V. Of course, V is a vector and C is a constant, whatever your set of scalars is. Okay. And first thing I ask, is this equivalent to this saying that T of C1 V1 plus C2 V2 equals C1 T of V1 plus C2 T of V2? Meaning that if these two things are true, does this have to be true? And if this is true, do these two things have to be true? In that case, they would be equivalent. So just an assignment of a fairly simple, straightforward exercise. Prove it, or if not, state why. Okay? Okay. Now, example of a transformation. That T of xy equals x1. Okay, T of the ordered pair xy, and it really should have an extra set of parentheses. Your book isn't using it, so I won't. Okay? So, to prove or to test the first condition, we see if, well, we take two different examples of xy's, okay? So we might call those x1, y1, and x2, y2, and see if T of v1 plus v2 equals T of v1 plus T of v2. Okay? So, when you started this, you kind of wrote it out like this. And that's what we're trying to test. Okay, well, here we're going to add the x1, y1 to the x2, y2, which will suddenly give us an expression without parentheses. We're losing some parentheses here, and we really shouldn't, but again, the book kind of does it, so I'll stay with them. Is this equal to, question mark, T? Well, T of x1, y1 is what?
X1, y1.
Yeah, it just says whatever is the first thing here, you put that here, and it doesn't matter what the second thing is, or the first thing, you put a 1 here. Okay? So that just means that this is going to be x1, 1, and this is going to be x2, 1. Okay? Now, what's T of x1 plus x2, y1 plus y2? Well, this says you take whatever's the first thing and you put it here. And no matter what the first and second things are, you put a 1 here. That's what you got to do. So this is going to be x1 plus x2, 1. Okay, kind of thought there ought to be a 2 there, because there's going to be a 2 over here. But that's what you're testing, and you're showing that it ain't so. Okay? Nope, T ain't linear. Okay? Now, ain't is much better than isn't, because isn't has 2 syllables. Why say 2 syllables when you can say 1? I just don't know about this language. Okay. It used to be considered grammatical. The wrong people were using it. And it also didn't fit with certain other rules of grammar. Grammar is more important than people give it credit for these days. You don't know what to expect when somebody says something that's totally ungrammatical. You don't know what they're saying. Okay? But that ain't the case here. Right. Okay, so T ain't linear. That, and also T of CV would not equal CT of V, because on CT of V, you'd have to multiply that 1 by C. But CT of CV would still give you a 1. Okay? And I think you can see that. Okay, well, let's look at a few others.